Okay. Yeah, right there. So, yesterday we multiplied two binomials together. So it was the two terms by the two terms. Today we're going to multiply something that has two terms with something that has three terms. So we're going to do a binomial times a trinomial. So, for example, let's see the quantity of x minus 2 times the quantity 3x squared plus 4x minus 1. Should probably write this out, yeah. It'd be a really great example to look back at and follow.
Do you ever check on
Would it be okay to shut off the light?
Shut off a light. You can move closer to see better. My light shut off this way instead of front and back, so it doesn't work out quite as nice.
Shut them all.
What? No, because then you can't see your notebook.
No, we can't.
I know that you're taking notes because I'm watching you do it during class. So.
Do you give us points on watching and taking notes? Or
Yeah.
check them?
I just make sure you're watching. If I see you guys taking notes, you're good. If I see you not taking notes, you're not good. Yeah, and then I give you points. You guys signed that syllabus at the start of the year. It was all on there. All right, so what do you think we would do here? Yes, Willie. Or Billy. Billy. I was combining your two names together.
The same thing, but
Yeah, the same exact thing. We're going to distribute, except for when we distribute the x, we just have to make sure we distribute it to the 3x squared, the 4x, and the minus 1. Okay, so let's take the x times the 3x squared. What will we get? Good, 3x cubed. Take the x times the 4x. What will we get? Good, plus 4x squared. And then take the x times the minus 1. What will we get? Negative x. Now, the one thing about this when we distribute this where we have two terms and three terms is that our like terms aren't going to be written right next to each other. Okay? So when we distribute the minus 2 through, I'm going to suggest that you line the like terms up vertically so you can see the like terms together. So if we distribute minus 2 to 3x squared, what would we get? Negative 6x squared. Which one is that like with? The 4x squared. So I'm going to put the minus 6x squared right underneath the 4x squared so that I know I should combine those two together. Minus 2 times 4x. What would that be? Negative 8x. So which one would we line that one up under? Negative x, yeah. Okay, and then negative 2 times negative 1. Positive 2. Is there a like term there yet? Nope, so we'll just put it at the end. Now we can look. We've already lined up the like terms together, so we can easily see to combine them.
if that's confusing, can we just write it off?
Yeah, you can write it straight out too if this is confusing. So what do we have when we combine it together? 3x cubed. What would be 4x squared minus 6x squared? Yeah? What would our next one be? Minus x minus 8x. Not 7. Minus 9x. And then plus 2. Okay, so now the alternate to this, if you don't like that, if you don't like doing it vertical, that's fine. You don't have to do it that way. The alternate way to this is when you go through and distribute it, is you would have a whole string like this afterwards. And then once when you're here, you would look and find the like term. So once when you're here, you would say, okay, here's my 4x squared with my minus 6x squared, and we get the minus 2x squared. Here's my minus x with my minus 8x, and I get the minus 9x. You're going to get the same answer. It's whichever way makes the most sense to you to do it. Okay? We'll do another one like this. So let's see, example 2. 5x plus 1 times x squared minus 3x plus 7. All right, so what would we want to do first here? Distribute. Okay, so 5x times x squared. Not 5x squared. 5x. Whoa. What is this really? 5x cubed, you said. I said too. 5x cubed. Good catch, guys. 5x times minus 3x. Yeah. Minus 15x squared. 5x times 7. Plus 35x. You guys like writing it as one whole string, or do you like lining up the like? You like the one whole string? Okay. All right, what do we continue on with then? The 1? 1 times x squared. What's that? Plus 1x squared. 1 times minus 3x. Negative 3x. Then 1 times 7. So 7. Okay. So where are our like terms?
X squared and 15x squared.
Okay. So negative 15x squared plus an x squared. There's nothing alike with the 5x cubed, though, so we'll leave that. So what would be negative 15x squared plus x squared? Minus 14x squared. So we have a 5x cubed minus 14x squared. Any other like terms?
35x.
Okay, 35x minus 3x. So plus 32x. And then we still have our plus 7. Does that make sense? It's just same thing we were doing yesterday. We just have one more thing. Yep.
Are we ever going to get anything like where we get it broken down like this and then there's going to be more that we have to combine into?
After this step, you mean?
Yeah.
No, once when you're here, once when you combine your like terms, you'll be done. Okay? All right, so I want to show you another way this problem could look, or a problem could look. What would we do if we had a problem like this? 2g plus 1 squared.
Maybe you just add the squares to everything?
No.
You do everything in squared.
Okay, so what does it mean for something to be squared? Like, if you have 3 squared, what does that mean?
Like, everything's or like, there's 2 of it.
Yeah, there's 2 of them, right? So it's times by itself. So if we see 2g plus 1 squared, how many 2g plus 1s do we really have? We really have 2 of them. So we're going to want to write out that this is really 2g plus 1 times 2g plus 1. Okay, so if we see that exponent, like that square, we need to write out that we have 2 of them. And then how would we be able to do this? Yeah, do the distributing. So 2g times 2g.
4g.
4g squared. How about 2g times 1? Plus 2g. How about 1 times 2g? Another plus 2g. How about 1 times 1? Plus 1. Are there any like terms that we can combine together? 2g's. So this is 4g squared, and then what? Plus 4g plus 1? Good. So is that one okay? Right, so now we're going to kind of combine those two ideas together for our last example. So, let's see. This will be example 4. Oh, let's do 3x plus 2 to the third power. Okay, if this is to the third power, what does that mean? We've got to write it out 3 times. So 3x plus 2 times 3x plus 2 times 3x plus 2. I won't give you 1 to the 5th power, no. All right, so we have it written out 3 times. How do you think we would do this one?
3 times 3 times 3.
We are actually, that's a good thought, but we'll get kind of confused with what we've multiplied and what we haven't. So what we're going to do is we're just going to kind of look at only the first 2 and just multiply the first 2 together. Okay? And then once we get that figured out, we'll multiply it by our last term. So we're just going to focus on the first 2. All right? So how do we multiply the first 2 together? Distribute. So we have 3x times 3x. 9x squared. 3x times 2 plus 6x. Then what do we distribute? Yeah. 2 times 3. 2 times 3x. What would be our 2 times our 3x? 6x. And then we have 2 times 2, which would be 4. Okay, can we simplify that?
Yeah.
So how will this simplify?
6x plus 6x.
Okay, well, what will we get when we do 6x plus 6x? Plus 12x plus 4. So is everyone okay with that first part? We got 9x squared plus 12x plus 4. Is that okay? Now, we didn't do anything with that last 3x plus 2, so we're going to write it at the end now.
So we're going to distribute all that.
So now we distribute all that. You can do this 2 ways. You guys have been distributing from left to right. Right? Does the order that we multiply matter, though? So could you distribute from right to left if you wanted to? Yeah. It doesn't matter which way you do it. You're going to get the same ending answer. Okay?
So would that 9x squared turn into 27x cubed?
Yep. So do you guys want to take this 9x squared and distribute it to both? And then the 12, and then the 4? Or do you want to do the 3x and the 2? Doesn't matter.
Switch it around.
Oh, so you want to take it and rewrite it the other way?
Yeah.
All right, let's just do that. Good thought. We can do that because order of multiplication does not matter. And now this looks exactly like a problem that we were just doing. Okay, so we switched it around. So what are we going to do first?
Times 3x with 9x squared.
Okay, so what's 3x times 9x squared?
27.
27x to the third. Then we have to take 3x times what?
12.
Okay, 3x times 12x. X to the
12x.
second. And then 3x times 4?
12x.
12x. Okay, what do we distribute next?
2.
The 2. So 2 times the 9x squared.
18x squared.
Good, 18x squared. 2 times the 12x.
24x.
24x. And 2 times the
8.
4 plus 8. All right, do you see any like terms in there?
Yeah.
Okay, there's a 36x squared plus an 18x squared. So we'll have our 27x to the third, and then what would be our 36x squared plus 18x squared? I just didn't hear you. I would. would try adding those again. Yeah, 54. Plus 54x squared. And then, any other like terms?
12x and 24.
Okay, what would be 12x plus 24x?
38.
Plus 36x, and then plus 8. Is that okay? All right. So we're just continuing on. Page 483. Problems 25 through 32. And 37 through 42. And 45.